period 3 elements under oxides. Number 2. So 2Na solid plus half O2 gaseous to form Na2O solid. 2Al solid plus 1.5 O2 gaseous to form Al2O3 solid. And P4 solid plus 5O2 gaseous to form P4O10 solid. Mg solid plus a half O2 gaseous to form MgO solid. Si solid plus O2 gaseous to form SiO2 solid. S solid plus O2 gaseous to form SO2 gaseous. Why do Na2O, MgO, and Al2O3 have high melting points? The metal oxides. These metal oxides form giant ionic lattices, therefore strong force of attraction between each ion, so a lot of heat energy required to break the bond / melt them. Why does Al2O3 have a lower melting point than you expect? The difference in electronegativity between aluminium and oxygen is not as large as you expect. Therefore, oxygen ions don't attract electrons. Oxygen ions don't attract electrons in metal-oxygen bond as strong or strongly. Therefore, the bonds in Al2O3 are partially covalent as they don't attract electrons in metal-oxygen bond as strong. 2Na solid plus 2H2O liquid form 2NaOH aqueous plus H2 gaseous, pH 12 to 14 of the sodium hydroxide. Sodium reacts vigorously with cold water, forming molten ball on surface, producing H2 gas. Mg solid plus 2H2O liquid form MgOH squared aqueous plus H2 gaseous, pH 9 to 10. Magnesium reacts slowly with cold water, forming thin coating of magnesium hydroxide on the surface of metal. Mg solid plus H2O gaseous. Magnesium reacts faster with steam to form MgO solid plus H2 gaseous. Acid plus base to form salt plus water. Na2O solid plus 2HCl aqueous to form 2NaCl aqueous plus H2O liquid. MgO solid plus H2SO4 aqueous to form MgSO4 aqueous plus H2O liquid. SiO2 solid plus 2NaOH aqueous to form Na2SiO3 aqueous plus H2O liquid. P4O10 solid plus 12NaOH aqueous to form 4Na3PO4 aqueous plus 6H2O liquid. SO2 gaseous plus 2NaOH aqueous to form Na2SO3 aqueous plus H2O liquid. SO3 gaseous plus 2NaOH aqueous to form Na2SO4 aqueous plus H2O liquid. Al2O3 solid plus 3H2SO4. Al2O3 solid plus 3H2SO4 aqueous to form Al2 bracket SO3 bracket 3 aqueous plus 3H2O liquid. Al2O3 solid plus 2NaOH aqueous plus 3H2O liquid to form 2NaAl bracket OH 4 aqueous. Aluminium oxide. Describing the structure of it is partially ionic, partially covalently bonded. It is insoluble in water, however will react with acids and bases forming salts. So partially ionic, partially covalently bonded, insoluble in water, will react with acids and bases forming salts. Why is giant covalent structure of SiO2? It should say, I just said it like this, and then to fill it in, like fill in the gap. Why is giant covalent structure of SiO2? Why is it insoluble in water? It is insoluble in water. However, it can also react with bases forming salts. Therefore, it is still classified as acidic. Even though it is insoluble in water, it can still react with bases forming salts. Therefore, it's classified as acidic. Then you've got P4O10 solid plus 6H2O liquid form 4H3PO4 aqueous. SO2 gaseous plus H2O liquid form H2SO3 aqueous. SO3 liquid plus H2O liquid form H2SO4 aqueous. State a key fact about simple covalent oxides of nonmetals. They form acidic solutions. Simple covalent oxides of nonmetals form acidic solutions and they form pH solutions around 0 to 2. They dissociate in solution, forming a H plus ion and a negative ion, or sometimes called as a conjugate base. Why are ionic oxides alkaline? Sodium and magnesium both have O2 minus ions. They dissolve in water accepting protons. So dissolving water accepting protons, forming OH minus ions, and yeah, that's why they're alkaline. Then you got your two equations you need to know as well. Na2O solid plus H2O liquid form 2NaOH aqueous, and this is pH 12 to 14. MgO solid plus H2O liquid form MgOH squared aqueous, pH 9 to 10. And you do need to know the pHs as well. And that is the end for this video.